Hello, friends, and welcome to our lesson number 4 in the Six Sigma. And before starting my usually introduction, I'd like to extend my prayers for that critical situation related to the coronavirus, which I hope it will end fast and all of you are in best health and wellness. Indeed, most of you are now working from home or stay longer time in home. And I think that this time can be efficiently and effectively utilized by reviewing or reassessing the operation processes, the strategies, empowering our weaknesses points through the facilitated online training or brainstorming workshops. And thanks to the technology, we still have the internet communication channels. Okay, today I will speak about the correlation and the causation, which is frequently used in the Six Sigma. And understanding the causation and the correlation is quite important, especially that all of us know that the philosophy of the Lean Six Sigma is mainly based on the equation y equal fx, or y is a function on x, where the Y is the customer demand or the targets that the customer care about it. And X are the X's are the factors contributing to achieve those targets. So understanding the correlation and the causations between the contributing factors X's and the Y's are very important to avoid investing time and money on factors that if you improve it, it will never reflect and change and improve the business performance in terms of operational and financial KPIs. Don't go away.
Okay, so let's now understand the definitions of the correlations and the causality and the difference between the both terminologies. The correlation is a statistical measure for the strength of relationship between two quantitative variables, while the causality is an indication that a certain event is a result of another event occurrence. As an example, um, if we want to conduct a correlation study between the car accidents, the daily cars accidents, and the daily drug sales, we might see a common causality which is related to the business overstress. As much the daily sales of drugs increase, as many more we might expect accidents. In fact, it's not necessary that the business overload is the only cause, but it might be also related to other factors, such as the traffic jam or spending long time in driving. In fact, there is a correlation factor which is mainly responsible to calculate the strength of the correlation. It's also known with the Pearson correlation R. If we look to the scatter diagrams, which are mainly used to calculate or to understand the correlation between the variables, in the first scenario, we can see a strong positive correlation, which can be seen through the residual lines. And if we just draw a trend line in between the points, what we can conclude is that the data points or the residual points are very close from the trend line. So that's why we can say that this is a strong positive correlation. While if we look to the second scenario, we still say that this is a positive correlation, but with less strength. Why? Because if we draw another trend line, we will see that there are a little bit gap between the residual points and the trend line. In the third scenario, we can see a strong negative correlation because the trend line is in the direction of the downward, and the distance between the residual points and the trend line are very close. While if we look to the last scenario, we will see that the data points, the residual the points are spread everywhere, so that it will be very difficult that I can draw a trend line upward or downward. And that will give us an impression that in this scenario, we don't have a correlation between the variables. Just to know that the correlation factor, in case that the value of the correlation factor is between 0.8 to 1 or minus 0.8 to minus 1, that is a strong correlation. The moderate correlation will be between 0.5 to the 0.8 or minus 0.5 to minus 0.8. The weak correlation will be between the 0.3 to the 0.5 or minus 0.3 to minus 0.5. And no correlation will be between 0 to 0.3 or 0 to minus 0.3. Few seconds and we will take a working example in where we can understand how we can get those values. As examples for the correlation, if we look between the sleeping hours and the blood pressure, we might have an inverse correlation. As lower sleeping hours we sleep, we might have a higher rate of blood pressure. In the second examples, we can have a positive correlation between the RAMs and the computer speed. As many RAMs increase, the number of RAMs increase, as higher will be the computer speed. So let's take a working example so we can better understand the correlation factor. First of all, here is the formula for the correlation factor. And in fact, the formula is the sample size multiplied with the sum of the x with the y, where x is the independent values and y is the dependent value. So we have two variables, x and y, minus the sum of x multiplied with the sum of y, divided by the square root of the sample size multiplied with the sum of the independent variable square minus the sum of the independent to the power of 2. And later on, I will take your attention for the difference between the both parameter. Multiply with the sample size with the sum of the dependent variable square to the sum of the dependent value to the power of 2. So let's take the example. A statistical studies center wants to find the correlation between the daily drug sales and the daily number of accidents for a certain city. They collected the data within 30 days as per the shown tabulated list. So here is my tabulated list. It contains the dates of the measurement. So they started from January 1 to the 31st of January, and they measured the daily drug sales in the city and the number of daily accidents. So we want to know if there is a correlation between the drugs sales and the cars accident. In that example, the drugs cells will be my independent variable, while the car accident will be my dependent variable y. So this will be the x, the daily drug cells will be the x, and the daily accidents will be the y. So here again, we replot the table of the data that we have. The daily drug cells is the X column, and the daily accidents is the Y column, or the dependent variable. So the X multiplied with the Y, that's 2,250 multiplied with 2, which is equal to the 4,500. And this is the X square, which is 2,250 square. And this is the Y square, which is 2 to the power of 2 is 4. And I repeat all these equations till the 31st of Jan, to the last row of the table. Downside, as you can see, this is the sum of the X, and this is the sum of the Y. And I have the sum of XY. And here I have the sum of the X square and the sum of Y square. So it's just now that I will follow the formula. So my n is the sample size, and it equal to 31, because I have 31 data in 31 days. And the sum of the xy is the multiplication of the both variables, the sum of the multiplications. Then I have here the value of the sum of all the x, which is the 69,598, and the sum of y, which is the 84. So here we have the sigma x to the power of 2. And in fact, this is not the sigma x square. This, sorry, the sum of x square. This is, in fact, the sum of the x to the power of 2, which is the 69,598 to the power of 2. And the sum of y to the power 2 is in fact the 84 square, which is equal to 7,056. And I have here the sum of the x square, which is the 237,875,132, and the sum of the y square, which is 504. So the last remaining step is to just fill up the parameters, the factors of the equation, and I get my Pearson correlation, which is 0.935. And if we refer back that this 0.935 is even higher than the 0.8, which is an indication of a very strong correlation. So even if we look to the scatter diagram and we look to the trend line, we can see that most of all the residual points are close from the trend line. I just want to show for, in case that we need to know the way of getting the scatter diagram from the Microsoft Excel. So the first step, that we copy paste the table in the Excel, then you will go to the recommended charts, and from there you can get the XY scatter diagram, and then you get your scatter diagram, and later on you can edit it as per your need, the titles and the X and Y axis. Even if you want to make sure about the correct results of your exercise, you might get the correlation factor directly from the Excel. You will just go to the number one, the data analysis in Excel. So you will go through the data, and from the data you will go to the correlation. You will choose the correlation, then you will have this window showing you the input range. In the input range window, you will have to cover the X and the Y columns, which is the both variables, and then you select the output range where you want your results, the cell location. And don't forget that if you highlight the both columns, including the titles, okay, so let me highlight it in front of you, okay, then you will have to click a check mark in the labels in the first row. So be aware that sometimes you might forget that you include the data, the titles of the columns, which might lead to giving you some kind of error message. So as you can see that the Excel, Microsoft Excel gave us the same result that we calculated, which was the 0.935. And we concluded that it is a strong correlation, a strong positive correlation. Now, a very important question is, why do we need the correlation coefficient? In fact, as we know that the philosophy of the Six Sigma is controlling the inputs of the process to control the outputs and gives a higher level of quality performance and customer satisfaction, which is known with the formula of the y equal the fx. So now, if you want to get to achieve certain targets, you will have too many variables, different factors that you need to improve, increase, or some other factors that you want to reduce. Because as we highlighted in the correlation, that we might have positive and negative correlation. But the most important point that before that you implement your efforts, you apply efforts to improve those factors, you need to make sure that there is a very strong correlation between those factors and the output. Otherwise, what will happen is that you might be losing time and wasting money. So that's one of the major steps that you have to do when you want to make validation for the solutions, or you want to ensure that you have chosen the right factor of improvement, the right variable of improvement. The correlation is a very strong statistical tool that will prove for you the importance or the value of that factor that you will invest time and money to improve it. I hope within those few minutes that I could explain to you the correlation coefficient. I thank you for your good listening and watching, and see you for the next time. Thank you.